Good day, class. For this class, I'll be taking you reproduction in unicellular organisms and invertebrates. So I would like to divide it into two. For this class, I will dwell much on asexual reproduction. You can see the forms of asexual reproduction enlisted on the board. We have binary fission, we have budding, sporulation, schizogony, parthenogenesis, then we have fragmentation. Now we know reproduction is essential to life, just to ensure continuity of life. Now, binary fission. Binary. From the word, please mind it not unequal division, it is equal division, so that two daughter cells at the end of the day, and the two daughter cells they grow to become new individual. This is a binary fission, as simple as that. The next one is budding. This is different from binary. Budding, okay, example of organism in which the amoeba. This is seen in amoeba fission. The next one is budding. Budding is seen in hydra. It is as well seen in obelia. The organism will just form an outgrowth, a small outgrowth out of its body. And then this outgrowth eventually breaks off from the main organism. And then wherever it lands, it starts a new life. This is body. The next one is geophore. During adverse environmental conditions, such as when the temperature is too high, when there is too much cold, or as a result of the organism trying to adapt to the effect of radiation, they now form spores. These spores, when the time comes, the sporangium is going to burst open so that the spores are released. And please mind it, this reproduction takes place when the conditions of the environment are adverse. Spores are going to form, they are going to undergo morphological changes, gene expression, so that the genetic content of the organism is preserved until the condition becomes favorable for them. The spores will now germinate. The spores that land will now germinate to become new individuals. We now have a replica of the rhizopus. That is a sporulation. We have schizogony. Schizogony, I can refer to it as multiple fission, in which an organism called trophocyte, the trophozoite, is going to increase in size. This is the let's say this is the trophocyte. It's going to increase in size, while the cell inside it will undergo many division, so that we now have nuclei formed from the nucleus. From the nucleus, we have nuclei. The organism will now break into many parts, so that we now have many daughter cells from a single organism. This is seen in Plasmodium. That is a malaria parasite. That is a schizogony. And the organism involved are called seasons. When after they have increased in size and after the nucleus has divided to form nuclei, they are called seasons. Don't forget, this is seen in Plasmodium. The next one on the list is parthenogenesis. Parthenogenesis. This one is called virgin birth. What do I mean by this? It is a form of reproduction, asexual, in which an egg develops without being fertilized by a sperm. That is parthenogenesis. This parthenogenesis can be divided into two. Parthenogenesis. It is divided into two, which are obligate parthenogenesis. Then we have facultative parthenogenesis. Facultative parthenogenesis. Obligate. The organism has no other means of reproduction than to comply with this parthenogenesis. That is obligate. It is compulsory because no other option for it. The other one is facultative. When organism that ordinarily relies on sexual reproduction is deprived of the conditions necessary for sexual reproduction to take place, this extenuating condition will now make it to consider asexual reproduction, which is asexual, which is a facultative parthenogenesis. That is a parthenogenesis for you, virgin birth. The last one, organisms in which this one can be formed is we have aphid. It can be found in aphid. It is also found in ants. Ants. It is also observed in honeybees. Honeybees. This is parthenogenesis. The last one here is fragmentation. Fragmentation, in which a part of the organism is from the parents, from that parent cell or the parent organism, just is a part will break up. It's unequal division, unlike binary division, which is what? Division into two equal halves. Now, the fragment that breaks off will now establish a new life elsewhere or wherever it is. This is a fragmentation. And getting straight away from binary fission. These are the forms of asexual reproduction. Now, still on unicellular organism, we want to take sexual reproduction in them because some of them can alternate between sexual and asexual form, like Spirogyra. Spirogyra can exhibit sexual reproduction, which is by conjugation. It can as well undergo asexual reproduction by spore formation. Now, to the sexual reproduction. I will take sexual reproduction in organisms, namely Spirogyra, and in Paramecium, in these two organisms. Now, conjugation in Spirogyra. We are going to have two filaments of spirogyra. As you know, spirogyra is a multicellular filamentous agar. Two filaments, we are going to have them, and then the two filaments will lie side by side. For reproduction, especially sexual, to be effective, there should be proper orientation of the nuclei that want to combine, or of the two organisms that want to combine. This is a filament of spirogyra. A filament, it has a crossword. This is a filament. This is another filament lying by its side. Proper orientation. The two filaments are going to develop outgrowth out of the body. Outgrowth. Now, this one can now become something like this. You have this, then we have outgrowth out of the body. This one also outgrowth out of the body. Outgrowth also out of the body. The other cell contents remain, but the only change taking place is formation of outgrowth out of the body. The two outgrowths will now, as you can see, they will develop, they will grow towards each other until they meet. Now, from here, we can take this now. The two of them meet here. You can see the two of them meet. But one thing you need to know is that the cytoplasm, the spirogyra has cytoplasm. When the two of them now cytoplasm from the cell wall, the cytoplasm will shrink away from the cell wall for you to have something like this. Meaning that this is not with this again. It has shrunk away from it. This one, it will now form a nucleus. Can you now see this one now form a nucleus? We now have nuclei, of which one is a female, the other one is a male. Or you can, the spirogyra filaments are of different strain, meaning male and female filaments. Now, at this stage, a conjugation tool is said to be formed. Conjugation tool. This is conjugation tool. The two filaments involved, they are called conjugants. These are the conjugants. Conjugants. Like a conjugant bliss. These are the partner. And name this male. This is male. This is a female. We now move towards the female filament. It will now move towards the female filament. Now this diagram becomes this. We have the two filaments already joined together. And the male content is now a zygote will be formed from the fusion of the two gametes, the male and the female gametes. Zygote is formed. This is zygote. Zygote that is formed. From the zygote, permit me to clean this filament that we started with, the conjugate. Now, zygote is formed. This zygote, a thick wall will now develop just to protect the zygote. To protect the zygote, thick wall will be formed so that the zygote becomes what is called zygospore. Zygospore. The two, we can see them. The two filaments, we can see them, and we have this zygospore. This is the zygospore now. It has developed from the zygote, surrounded by thick wall. Thick wall. This one now is called zygospore. Zygospore. This zygospore. This zygospore now fully mature to become a new spirogyra filament. A new spirogyra filament. And when the filament is formed, when it is fully formed, we are going to have the cell wall disintegrating. The cell wall, we are going to have it disintegrating. It will disintegrate to release the zygospore. You now have something like this. The two filaments are this, and they are already joined together. Already, and the cell contents have been exchanged, in which male migrates into the female to form zygotes. Thick wall surrounds this zygote to form zygospore. The zygospore that is fully matured or that has fully germinated will now be released. This is now a new spirogyra filament. A new spirogyra. The zygospore. New spirogyra in which you have the cross wall. When the cell wall has disintegrated to release the new filaments. The new filaments will now stay